All right, good afternoon or good morning, depending on where your location is today. I am Scott Gannett, Director of Marketing for Hirose Americas. It's my pleasure to welcome you to today's webinar on connector technology that enables LiDAR-based ADAS systems. I am very excited to introduce Carrick Kalanick, a regional sales engineer from our automotive team at Hirose Electric Americas. Carrick has a bachelor's degree in nuclear, plasma, and radiological engineering from the University of Illinois. Carrick's an expert on connector technology within the automotive and autonomous vehicles. As part of the Hirose team, we're here to support your electrical designs in LiDAR-based and ADAS ecosystems. So it's really clear that in the automotive industry today, it's traveling rapidly towards advanced autonomous vehicles and assisted driving technologies. Connector technology plays a critical role, not only within the autonomous system components themselves, but also linking the systems and exchanging data across the entire vehicle ecosystem. So before we get started, just a quick reminder, please put your mic on mute. That little icon should be at the top of center of your screen. During the presentation, you can always, if a question comes up, please enter it in the chat so you don't forget. And then at the end of the presentation, we'll do a Q&A session, and I'll cue Carrick with all the questions from the Q&A right at the end. In addition, don't forget that as part of a thank you for attending today's session, we will be providing sample kits that include some of the connectors we're discussing today. So with that, I am very excited to pass the mic over to Carrick.
Thanks so much, Scott. I'm super excited to do this today. Let me start my screen share. Hi, this is my face. So today I'm going to talk about LiDAR and its applications, and then I'll address some common challenges engineers face when they design LiDAR for autonomous vehicles. So with that, what is LiDAR? LiDAR works by sending lasers out to the surrounding area and measuring how long it takes for the light to come back to the sensor. This information allows the sensor to create a 3D map of the surroundings. LiDAR can detect the distance of objects more accurately than cameras. So while LiDAR may be more expensive than cameras or radar, they serve a unique purpose in the autonomous vehicle architecture. LiDAR is used for many important things right now, first of which is topographical mapping. By mounting on aircraft, LiDAR systems are able to research forest and seafloor patterns. You can also aim LiDAR at a crop field or building to see which areas are facing crop failure or building erosion. Depending on the frequency of the laser used, LiDAR lasers can detect particles in the air, allowing us to research production and migration of aerosol clouds and optimize the location of wind farms. With a different frequency laser, it could also be useful at great distance, which means you could make a topographic map of the moon or other distant objects. As processing speeds increase, small LiDAR sensors can quickly and accurately scan long distances, allowing vehicles to avoid obstructions while traveling even at high speeds. This enables the automation trend in warehouses, aircraft, and cars, which is, of course, our topic today. To fully understand the environment around them, ADAS systems are equipped with three main types of vision. Cameras are placed all around to make sure the driver can always see many areas. And these cameras mostly allow the car to drive itself or see everything. But at high speeds or low light, cameras struggle to accurately determine distance of obstructions. Radar and LiDAR sensors with various ranges are used for parking assistance and collision detection in situations where cameras aren't very reliable. So here this slide shows the volume of vehicles with LiDAR sold over time. The market is projected to experience rapid growth beginning this year. So as soon as this webinar is over, we should all go buy some stock in the LiDAR industry, I would say. Structurally, there's a few main types of LiDAR designs. What I'm mainly talking about here is scanning methods. Mechanical LiDAR consists of a spinning laser emitter, which comes with the benefits of greater range and better resolution, but at the cost of maintenance, high cost, power consumption, and heat management. On the other hand, solid-state LiDAR does not require the whole unit to spin. Instead, the environment's scanned by using a spinning mirror or optical phased array, like in the case of the little cell phone LiDARs. Flash LiDAR works kind of like a camera. It illuminates the scene all at once and measures the time of flight of the lasers. As an automotive FAE for a connector company, I've spoken to hundreds of customers about connector-related issues, and I've noted the most common challenges they face when working with electric connectors. When designing ADAS devices for automotive environments, these on this page are some of the most common challenges engineers face. I've broken them into 4 sections. The first section is increasing performance requirements from the industry. New cars need to transfer massive amounts of energy and data between and within the modules, forcing engineers to seek out connection systems with fast data transmission, shielding, and high power ratings. High-speed transmission can be compromised if electromagnetic interference is bouncing around the box too much. GT32 here is an example of how a connector can be fully surrounded by a metal shield so that it doesn't allow any EMI in or out of the connector. Continue with EMI. Hirose has found a lot of success selling high-speed floating board-to-board connectors to automotive customers. But recently, as engineers face more EMI issues, some have required a connector with an integrated shield plate and grounding tabs. To complete the lineup of EMI-resistant connectors, this FFC connector can accept shielded FFC cable and contains dedicated ground contacts. As the most cost-effective way to transmit high-speed signals within a module, shielded FFC connectors don't have to sacrifice signal integrity to maintain cost effectiveness. So talking about data rate, 10 years ago, cars relied on CAN bus signals to send data. Data rates for CAN bus can be up to maybe 5 MB per second, while the latest ADAS sensors transfer data at PCIe Gen 4 speeds and maybe even faster, which corresponds to 16 gigabits per second. So that means that connectors like the one on this slide can send data 15,000 times faster than traditional connectors without compromising signal integrity. As EV batteries increase in efficiencies, higher voltage connections are required while maintaining small form factor. For this reason, Hirose can remove pins from this popular wire-to-board connector, which increases the creepage distance and enables voltage ratings well over 1,000 volts. Now, this is a little bit unique. Engineers typically think of using discrete wires only for high current or battery connections. However, the latest Hirose FFC connectors can also be used for 6 amps or higher. Using FFC connectors for power can lower costs and save PCB space. All right, second section. One of the most obvious challenges ADAS engineers face is designing a system that can withstand the vibration and temperature within a car and to maintain reliability over thousands of hours of drive time. To keep cars safe, components are required to pass rigorous and extensive testing. For connections between modules, ingress protection is critical. Often, water immersion as well as pressure wash tests must be passed. IP67 or 68 correspond to water immersion testing, while IP69 corresponds to pressure wash testing. To protect the inside of the module, this connector contains gaskets in the panel, housing, and wire entrance. One of Hirose's main strengths is designing small connectors with high contact reliability. In connectors like this one on the screen, each male contact touches each female contact in 2 places with 2 separate springs. This minimizes the risk of momentary signal disruption from dust intrusion, shock, or vibration, which are big issues in this industry. In microconnectors, the contacts are so tiny that they can be damaged by human hands if the assembler is not careful. Through Hirose's long history of designing really tiny microconnectors, the contact shape has been optimized to minimize the risk of buckling due to uneven or forceful mating. So here is a video about that. This is actually a latching, sorry, pause. This is a latching micro board-to-board connector. Both sets of PCBs are dropped from 7.5 feet. And here you can see the unlocked PCB is going to bounce off while the locked PCB remains on the board. I'm just going to let that play again. So about 1.5 meters. We put a little lock on the connector, and then one of them bounces right off. That would be the one without the lock. When considering the retention force of a wire-to-board connector, there's 3 places the connector could break. First, the connector could peel off the PCB if the surface mount pads aren't big enough or soldered properly. The pads for each signal are less than 1 millimeter squared. So that's not big enough to keep the connector strongly attached to the board by themselves. So to obtain 25 newtons peel-off strength, mechanical mounting terminals have been added, which we call retention tabs. Next, the second way it could break is the plug could come out of the socket if the lock breaks, which is why an extra strong lock is added. Finally, cables could be pulled out of the crimp socket. Since each wire is held to the crimp socket by guaranteed 12 newtons, 24 plus newtons may be able to rip 2 cables out of the socket, making this the first mode of failure. If more than 2 wires are used, then the first mode of failure would be probably peeling off the PCB. Sticking with the topic of retention force, some FFC connectors, especially old ones, can have the cable torn out of the receptacle with minimal effort. To combat this, Hirose's latest flex connectors are compatible with FFC retention tabs. They hook in by this little blue arrow on the left, and then they're locked in place when you flip the flip lock down and closed. Retention tabs increase retention force by a factor of 3 or 4, but that doesn't mean all connectors with retention tabs are the same. When measured against competition, Hirose's FH75 series exhibited higher retention force by a significant amount, as you can see in the graph. As ADAS sensors increase in performance and decrease in size, board-to-board connectors are becoming more and more popular. As ADAS is crucial to human safety, board-to-board connectors absolutely need to have a floating feature to handle harsh vibration and absorb misalignment. So I've got a video for that. So here you can see the PCBs noticeably move as our hand model twists them. As Scott mentioned, we're always happy to provide samples so you can try it out yourself. So feel free to let us send you some of those samples. All right, moving on to temperature. LiDAR sensors, along with most other automotive components, need to be able to withstand high temperatures. As heat is applied to the plastic housings of connectors, some shrinking can occur. Due to the contact structure of GT50, heat shrinkage of the plastic causes the contacts to be pushed together rather than apart. This, coupled with the two-point contact design, is what allows this connector to be used in harsh automotive environments, even though it's very small. All right, test reports. So throughout this presentation, I've been talking about the harsh environment in which ADAS sensors are used. To be more specific, let me give a summary of each common test that connectors are subjected to. Yeah, it looks like you can see my mouse. So vibration testing typically includes various frequencies, acceleration of at least 2 Gs, and at least 8 hours on each axis. Shock testing is similar to a drop test, except the deceleration is a lot more intense for things like this. Moisture resistance is measured by exposing the connector to 90% humidity for 96 hours. Thermal cycling quickly brings the connector from the lowest rated temperature to the highest rated temperature and repeats for 1,000 cycles. And finally, long-term heat and cold exposure is tested by leaving the connector at its lowest and highest rated temperatures for 1,000 hours. LiDAR and other ADAS sensors are designed to be very compact, and traditional automotive connectors are actually really bulky. With that said, let me show you some ways engineers are fitting more into smaller spaces. All right, back to this GT50. You know I love this one. This wire-to-board connector accepts 28 gauge wire, which is very small, but still big enough to handle 2 amps per pin. When compared to conventional small wire-to-board connectors, which use 22 gauge wire, we see a dramatic reduction in size and weight. To really understand how small this connector is, I again want to encourage you to get some samples. Flip-lock FFC connectors are perfect for decreasing connector size and cost. As manufacturing precision increases, engineers are able to use connectors with smaller and smaller pitch. As more and more signals are added, saving 20% flexible cable width could have a notable impact on available PCB space. Another way customers are saving space is by consolidating power and signal connectors into one connector. Board-to-board connectors like this one contain many signal contacts as well as 4 power pins, which are each conservatively rated to 3 amps. When it comes to board-to-board connectors, the floating structure takes up a bit more space than non-floating contacts. For LiDAR engineers, this can be a difficult trade-off to navigate since connectors need to be small and floating. BM54F is a brand new connector design which pushes the limits of how small a floating automotive connector can be. All right, last section, flying through it. As we all know, vehicles are produced in huge volumes due to high demand and economies of scale. The higher the volume, the more critical it becomes to optimize the manufacturing process. Board-to-board connectors can break if they're not aligned when mated. And automated assembly lines have a tolerance associated with mating connectors, so it's not always perfectly aligned. Large tapered guideposts, in addition to floating features, allow board-to-board connectors to easily mate together despite the misalignment. As I've mentioned before, Hirose really takes pride in the contact structure of our connectors. In micro board-to-board connectors like this one, a longer effective mating length gives a much stronger snap-in feeling and tactile click. This provides a clear indication the connector is mated, also increased retention force, and it can absorb a small amount of misalignment in the Z direction. For the same connector, we have this test jig type. For quality control, connectors can be electrically tested while on the production line. To make it easier for customers to do this, Hirose offers a high mating cycle version, which can be attached to the test jig. Without this test jig type, the connector on the test jig would need to be replaced every 30 tests, or otherwise an expensive custom test jig would need to be created. Hirose's one-action lock flex connectors are a great example of a product that was designed to optimize the manufacturing process. The receptacles come with the lock closed, and the cable is inserted while the lock remains closed. It may not seem like it takes much effort to flip the little latch to manually lock the cable, but as volume increases, the time and scrap saved from this enhanced process becomes very significant, especially if you have a lot of broken end products. That just started playing. Okay, I've got a real video anyway, so I don't care if the clip played. Almost got it. So here you can see someone mates 5 connectors by hand, and it only takes about 7 or 8 seconds total. But you may ask, what happens if a human's not mating those and a robot's mating them? When you mate one of those by hand, you can feel the tactile click. But if a robot's used to mate the connector, it may not be able to feel the click. Instead, the latest connectors can be visually confirm the connector is mated, which cameras can easily be used to confirm the mating, as the color is different between the fully mated and partially mated states. And we all know cameras are really good at color detection. All right, this is kind of a little summary slide for you guys. That's all I have for you. Thanks so much for attending the webinar. Whether or not you use Hirose connectors, I hope you will continue to leverage Hirose's experience in the ADAS industry to enhance your next generation designs. If you have any questions, please keep putting them in the chat, and feel free to email me anytime directly after the webinar ends. Thanks.
Okay. Carrick, excellent. Thank you for all that information. I do have a couple questions that have popped up in the chat, so let's jump into those. Folks, you can see Carrick's direct email down there. If you have any questions, please feel free to shoot Carrick a direct email. First email or text, chat response that I got is, can Hirose support SI simulation needs?
Yes, Hirose can. We have, about a few thousand engineers in Japan, but in the USA, we actually have a team of SI experts, which are dedicated to supporting our American customers with simulations and test reports.
Excellent. I got another one here. Hirose parts, this is a question kind of surrounding availability. Are they available through distributors, or do I need to get automotive parts directly through Hirose? Are they available to everyone, or just large companies? Who are the parts available to, and how can they get them?
Parts are available for everyone. I talked a lot about high volume needs, but if you're a startup and you just need a few parts, we work with several of the largest distribution companies.
Excellent. Okay. Are there any, I'm going to open this up to the floor now. So folks, if you have any additional questions for Carrick, please feel free to go ahead and just unmute your mic and go ahead and ask. Does anyone have any additional questions?
I think I see one more.
Okay.
So how does Hirose contribute to the advancement of the ADAS industry?
Oh, good one.
I would say the main way Hirose contributes to the industry is by collaborating with our customers and projecting the voice of the customer back to our design teams. Hirose works with a lot of cutting edge companies at the very beginning of their design. So during that collaboration, Hirose presents concept parts that are not designed yet to see interest level and what connectors might be needed in the future.
Let me turn it. Do we have any additional questions after that? I was starting to talk there and I was on mute. Nope, it's sounding like no additional questions. All right, well, we want to thank everyone. Just as a reminder, folks that have participated in today's webinar, we will be reaching out to you. We do actually have prepared a sample kit of, oh, wait, I got another question here. Does your FPC portfolio support both copper and aluminum cables, Carrick?
You know, I may have to get back with a confirmation on the for sure answer, but I believe the answer is no, we do not.
Okay. I can see who that came from, so we'll reach out to you directly. The person that posted that question, we can check that and reach out to you directly on that. Okay. Are there any additional questions? Again, you can unmute your mic or drop it into the chat there. Okay.
I think I see another thing.
Go ahead.
Does Hirose set the standards for the applications, or is it a joint effort between Hirose and the company working with? Typically, the OEMs, the final manufacturers, are setting a lot of the standards for testing. And then Hirose has to, maybe we did our own testing and we have to kind of adapt or redo testing or kind of compare the different testing that we've done with the OEM requirements.
Does it make sense to cover just quickly, maybe super quickly, some of the different standards that we work with? Obviously, there's I'm seeing people are probably familiar with like a U.S. car, but are there any specific ones for autonomous driving systems or things like that, or different other ones in other countries that you might want to point out?
No, actually, what I want to say there is this is a brand new industry. You saw that graph where everything's about to shoot up. There is no established standards really. This is all, each company kind of takes their own approach a little bit.
Okay. All right, so I was just starting to wrap up. As reminding folks, feel free to email Carrick directly with any additional questions. And as a reminder, we'll reach out to folks and coordinate to get sample kits. As I mentioned, we do create a sample kit that's based upon the presentation that we just went over here to provide some of those samples to you as a thank you for joining us here at the webinar today. And so we'll be reaching out to everyone to provide those. So, Carrick, any closing comments before we finish up?
Nope. Just look forward to the next webinar.
Thank you, everyone, for attending our webinar today. We really appreciate it. And thanks for joining us, and have a great day.